Hello everyone. Today, I would like to introduce SoPIoT, which is Service-Oriented Platform for IoT. Our platform has been developed by researchers of Co-Design and Parallel Processing Laboratory in Seoul National University in Korea. There exist many IoT platforms that have different features and limitations. They can be classified into two types in terms of communication structure between devices. Some platforms allow direct information exchange between devices, denoted as device-to-device structure. However, it is hard to manage the IoT system as a whole and vulnerable to security attack. Another type of platform is web-based, meaning that devices are connected to a web server that mediates the communication between devices. However, it requires the high overhead of supporting web protocol to the devices. In addition, since communication latency is likely to vary dynamically, real-time performance cannot be guaranteed in general. To overcome those issues, we have designed SoPIoT that each device is abstracted into services, then managed by the local middleware as user requests. We support for both constrained and unconstrained devices. In case of constrained devices, they are connected to middleware through gateway that translates communication. All communications between devices are managed by a local middleware, and all of the data are sent to an administration server that collects big data from IoT devices. A user can define a composite service dynamically through a script editor. Our key features can be summarized as follows. First of all, SoPIoT supports device abstraction as service that can easily integrate any computing resources. Second, it provides programmability that allows user to request a composite service at runtime. Third, all of the communications between devices are controlled by centralized middleware. Lastly, SoPIoT supports scalability of the platform by forming a hierarchical middleware structure. In SoPIoT, a device is registered with a set of services, which is abstraction of its functionality. A cloud application can be regarded as a virtual device in the system. As shown on the slide, a commercial smart bulb and Gmail can be abstracted into values and functions that represent services of a device. A user can specify a composite service with a script programming language through a script editor. The list of services that are registered to the platform are shown on the left side. With this information, user can write a script program to define a composite service. Registered composite service list is shown on the right side. User can stop or restart them just by changing its status. To support easy development of composite service by a user, a high-level script language has been devised. There are three kinds of control construct that can be expressed by the script language. A conditional execution of services is expressed by an if construct, and iterative execution of services by a loop construct. Lastly, we can block the loop execution until a certain condition is met, which is expressed by the wait until statement. This is an example composite service that could be defined when a user leaves the house. The script language description of a composite service is translated into a service graph. Since there may exist many composite services defined and running concurrently, mapping and scheduling of services to devices are necessary. Therefore, a variety of scheduling problems can be induced from the middleware, depending on the system characteristics. For a given set of requirements and assumptions, finding an optimal schedule is an open problem to research in the future. To demonstrate our platform, we have tested two example scenarios. The first example is a composite service that turns the lights on when it's dark and turns them off when it's bright. Through script editor, user can write composite service easily. When light sensor is covered with hand, lights are turned on, and when hand is removed from the sensor, they get turned off again. User can stop composite service just by clicking Stop User Interface. When composite service is stopped, light does not get turned on anymore, even if sensor is covered with hand. Second example is a scenario that turns on the TV if someone sits on the chair and tell voice sensor to turn on the TV. When someone leaves from the chair or tell voice sensor to turn off the TV gets turned off. Hi Cell, turn on the TV. Thank you for your attention. See you in the AC.